In this video, I'm going to introduce three of the simpler rules from 7.3, which marks the beginning of the rules of replacement. So these rules are a little bit different than our first 8 rules, which were the rules of inference, for a couple of different reasons. First of all, these rules of replacement here in 7.3 need not center around the main logical operator. I'll talk about that point here momentarily in a little bit more depth. But again, for now, these rules of replacement need not center around the main logical operator, meaning that they can be done to one side of the statement or the other, or perhaps in certain cases even both sides, one side at a time. So let's jump in to our rules here. And again, in this video, I'll just go through the easy rules from this section. There are a couple that are a little trickier than the others. So rather than proceeding in numerical fashion, as you might expect, I'm going to jump down actually to our last rule in this section, rule number 13, as it's labeled in the text. Rule number 13 is double negation, and we'll just abbreviate that for short as DN, double negation DN. Double negation you can get down inside of 30 seconds. All double negation allows us to do is either add tildes in multiples of 2 or take away tildes in multiples of 2. So for instance, if we start with, say, A, just a generic example here, we can, via double negation, take that A and turn it into not A. Justification would work like this. Line 1, double negation, DN. And that's really all that there is to rule number 13. Again, either add tildes in multiples of 2, as I've done here, or we can go the reverse direction. If we start, for instance, with not A, I can do double negation by taking away those 2 tildes and getting out A. So it can go either direction, which is precisely what's meant here by these 4 little dots. The visual explanation of DN given in the text is P ... not P. You can think of these 4 dots really as a two-way street. You can go either direction, either left to right or right to left. You can take something, in other words, that looks like this and turn it into that, or the other way around. You can start in this direction and go here to the left. And really, that's all that there is to double negation. A couple of points here to make note of before we move on to our next rule. When you're adding, or for that matter, taking away these tildes, you can't spread them over 2 separate variables. For instance, suppose that we had A or B. Now, double negation allows us to add or take away tildes in multiples of 2. So you might think that you could split this over 2 variables. Let me add one to the A and one to the B. Here I've added 2 tildes. Well, this doesn't work. Again, it can only be done to a single variable. You can't split it, you can't distribute it, in other words, over these 2 separate variables, the A and the B respectively. And of course, this wouldn't work in the other direction as well. You can't take away 2 tildes when they're separated, one on 2 different variables. You can't take away one from the A, one from the B, and think that that's double negation. Only with respect to a single variable, or for that matter, an entire statement put into some sort of grouping, for instance, parentheses. Suppose that we had A or B. I could double negate the A, I could double negate the B, or if I wanted to, if I needed to, I could put the entire thing in parentheses and double negate the entire statement. Why do you need to do double negation? Why is this a useful rule? Well, most frequently it's used in conjunction with either modus tollens or disjunctive syllogism. Let me give you a couple of examples of that. For instance, suppose that we had, say in line 1 we had A horseshoe not B, in line 2 we had just simply B, and the conclusion we were asked to derive were not A. Well, A only appears once here. It's the antecedent of a horseshoe statement. What rule allows us to get out the negation of an antecedent of a horseshoe statement? Well, one of our very first rules, of course, modus tollens. But to do modus tollens, you need the negation of the consequent. The negation of the consequent is not B. The negation of that, of course, would be not B, which we don't have. We're just given a B by itself. So we want not B. We've got a B. Well, we can create that not B just simply by doing double negation to line 2. That'll give us our not B. And now 1 and 3 modus tollens, and we can get not A. So that's a common usage of double negation. Really, most generally, it's used as an intermediate step to set up some other rule. So using it in conjunction with modus tollens, as I've done here, is quite common. Also, in a similar fashion, using double negation with disjunctive syllogism, DS, also something that comes up quite frequently. So double negation is a rule that's really simple and ought to make really good sense to you. Think, for instance, of a double negative in English. Here the double negatives sort of cancel each other out. So that's double negation.